now, coming to you live from west of the Rocky Mountains, Foundations in Pre-Calculus Math 10. Dance. 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 Today, section 1.4, surface area of right pyramids and cones. Alright guys, we're going to get right into this here. You can find this page on Canvas, print it out, and fill it in. Fill in the blanks. A right pyramid is a 3D object with triangular faces and a base that can be any polygon. The shape of the base defines what kind of pyramid it is. For example, you can have, in the diagram here, we have a square pyramid. You could have an octagonal pyramid if the bottom was an octagon. You could have hexagonal, etc. Or I want to mention a special one here, a tetrahedron, which has a special name because the base of a tetrahedron is also a triangle. So it has a triangle base, or a triangular base. The top of the pyramid, tricky one here. Oh yeah, the top point of the pyramid is known as the apex. And the height of the pyramid is the distance from the apex to the base at a right angle. Essentially what happens is apex directly down to the center of the base at a right angle. Okay? This is why we call it a right pyramid, by the way, because it hits the middle at a right angle. Let's scroll a bit here and keep going. If the base is a regular polygon, then all of the triangular faces must be congruent or identical or the same. The height of the triangular faces is also known as the slant height of that face, or if it's regular, then it's the slant height of the pyramid. Just go back up to our diagram for a second. Since this is a square base, the slant height would be this length here as seen on that face. It's going to be the same on all of the faces, and it's actually pretty easy to calculate because if you know the height from the apex to the base and you know the side length of the base, of course right in here you have a right triangle, and you can take half of the length of the side as that value there, and you've got the height, and you can Pythag it out. When you're measuring surface area, the units of measurement are always square units. Area is a square measurement, not a linear measurement. And examples, they are written as square centimeters, square meters, square inches, square feet. So for metric we use the exponential notation, and for imperial we often use the SQ, but I think it would be okay to also say square inches this way and square feet with the square symbol after the feet. I often have students read these as centimeters squared and meters squared. I know what you mean, but properly, technically, they are known as square centimeters and square meters. A few examples down here in the bottom. Of course, this one here is your tetrahedron, and over here we have the pentagonal pyramid, and once again another square pyramid where the base is a square. Alright, a right rectangular pyramid has base dimensions of 10 meters by 14 meters and a height of 8 meters. Calculate the surface area of the pyramid to the nearest square meter. So I think we could take this diagram, which is clearly not to scale, and label a few things on here. We'll put the 10 meters on the left and the right sides, the 14 meters front and back, And the height, of course, from the apex down to the base at a right angle, height of 8 meters. When you want to get the surface area of a pyramid like this, or indeed any object, what's often useful is to consider what it would look like if you snipped it along its edges and just deconstructed it. I think you can see that this one would end up giving you a rectangle in the middle and 4 triangles, top, bottom, left, and right, if you laid the whole thing flat. And clearly the triangles on the left and the right are going to have the same dimensions, and the ones on the top and bottom will have the same dimensions. So we can work forward from this by considering here what is the slant height here on the right hand side, and we'll use this right triangle to help us out with that. This has a length of 7 meters across the bottom, 8 meters vertically. So to get that slant height, 8 squared plus 7 squared equals the slant height squared. That's 64 plus 49 equal to s squared. So I think that we'll get s is equal to the square root of 113. I don't want to round that off just yet. I'll leave my rounding to the end so I can get my final answer to the nearest square meter. Calculating the area then of the triangle on the right hand side, area is 1/2 of base times height. This is 1/2 of 10 times root 113, which gives me 5 root 113. Now that's just the triangle on the right hand side, considering there's actually one on the left hand side as well. The area of both of those triangles is going to come out to be 10 root 113. I'll multiply that on my calculator later. Now let's consider the triangle on the front. In order to get its slant height, I want to consider the right triangle that sits right here, so that there's a right angle right there in this corner. This would be a length of 5 right here, half of the 10, and again 8 vertically. So to get that slant height, 5 squared plus 8 squared equals s squared. So I've got 25 plus 64 equal to 89 for my s squared. So s is going to be equal to the square root of 89. Again, I won't round this off for now. The area of that triangle for the front and the back is going to be 1/2 the base, which is 14, times the height, which we've just said is root 89, giving us the front triangle's area of 7 root 89. And so in total, the front and back triangles are going to be 14 root 89. Now, to complete this and get the area of everything, we also need the area of the base, which is, of course, a rectangle of dimensions 10 by 14. We know that area of a rectangle is length times width, so this is going to be simply 10 times 14. That's 140 square meters. All of these units here, square meters. So I'll get my calculator out now, and we will add these together. So 10 root 113 plus 14 root 89 plus 140 adds up to 378.3. So to the nearest square meter, this is 378 square meters total surface area for this pyramid. You can also just consider the sides, the lateral surface area, which would just be these two added together. Going back to my calculator, if I just take 140 off of this, that's 238. It's not unreasonable to consider just the lateral surface area for this question, because of course a pyramid that's 10 by 14, I'm not sure you could actually pick it up to even look at the base to even consider calculating its surface area as part of the whole thing. But the question didn't distinguish, so we will put it all together as 378. So taking what we just found on that one and bringing it over to this square pyramid, we can make some interesting generalizations. Of course, the area of one of the faces is a triangle, so it's half base times height. If you have a square base, you could call the length of one of the sides L, and of course you've got your slant height in here as S. So the area of that face is 1/2 L times S. So to get all four of the faces, that would be 4 times 1/2 LS. Now I recognize you could do 4 times a half, getting 2 LS, but bear with me as I do a slightly different manipulation. I'm going to take half of S and show that multiplying by 4L. And I want to highlight the 4L because if you consider what 4L means, 4L is the perimeter of the base. And so you could generalize this to say that the area of just the triangular faces, which, as I've mentioned, is called the lateral area, noted as A subscript L, the lateral area of any regular pyramid is 1/2 the slant height multiplied by the perimeter of the base. And so it doesn't matter if your base is a regular hexagonal base or octagonal base, as long as the base is a regular shape, all sides equal, all angles equal, then the lateral area is 1/2 slant height times perimeter of base. Brilliant. This allows you then to say that the area of the total of the entire pyramid is the lateral area plus the area of the base. And of course, if the base is a square, easy enough to calculate. Whatever the shape is, we have ways of calculating those areas. So what does this tell us then about the surface area of a cone? Well, it turns out that we can calculate the surface area of a cone in exactly the same way. The lateral area plus the base area. How do you get lateral area? Well, again, 1/2 S times perimeter of the base. 1/2 S times perimeter of the base. The base is a circle. That's called circumference, and circumference is equal to 2 pi r. So this is 1/2 S times 2 pi r. That's the lateral area plus the area of the base, again a circle, pi r squared. In the left here, something nice happens. A half times 2. Those two will cancel each other out, and so our formula simplifies to pi rs plus pi r squared for the surface area of a cone. Okay, today's 2 for you question.
2 for you!
Well, it's kind of just 1 for you, but what I do want you to do is calculate the surface area of this cone to the nearest 1/10 of a square foot. What are you going to have to do along the way? It looks like somebody didn't give you the slant height. How could you get that? Oh well, I'm sure you'll figure that out and then go ahead to calculate the surface area. Well, that's all the time we've got for today. So until next time, keep your pencil sharp, and I'll be seeing you in class. If you excuse me, I've got to get back to air traffic control. Delta 573, I've got you on a heading.